Yeah. Hello, everyone. Good evening. Welcome back to our weekly series where we talk about the various projects. So now, in front of you, today we have one project, energy optimization in steel manufacturing plant. So let me introduce myself first. Myself, Kunal Gokul Borse, and I'm working as a trainer at 360DigiTMG and also junior data scientist at AiSPRY. So, so, in this slide, let's talk about one scenario. Okay. So here we have two people who are competing for the job, Mr. and Mrs. A and Mr. and Mrs. 360. Okay. So here Mr. A trained at XYZ Institute who work on dummy projects from Kaggle, GitHub, etc. And other side we have Mr. 360 who trained at 360 DigiTMG who work on a real-time projects, attended daily stand-up calls, created end-to-end pipeline, deployed on-premise and on cloud, attended daily client meetings, research paper published in international journals. So here you can see the clear difference between these two, and you can take a guess for yourself as who will get shortlisted for the job or whose resume will get shortlisted. Okay. So without any delay, let's move further with our project. So first, let's understand how steel manufacturing process happens through this diagram. So in the steel manufacturing, we start by preparing a raw materials like cooking coal, iron ore, and other scrap materials. So cooking coal is turned into the coke, which is used in a blast furnace along with the iron ore and sintered to make the molten iron. So this molten iron then transferred to the electric arc furnace. We can say that EAF. So where it melts with the scrap metals and other metals like hot briquette iron and direct reduced iron in the electric arc furnace. So we carefully control the temperature and energy to melt the materials properly. So the chemical analysis of the steel happens in the electric arc furnace, where we check and adjust the elements like carbon and silicon to ensure the steel is right type or not. So once melted, then the steel moves to the ladle furnace. Okay, for the small adjustment like chemical composition. So chemical mix to get the right grades, steel grades. Okay, so after that, the steel goes through the vacuum degasser. Okay, which removes any unwanted and dissolved gases which are trapped inside the steel. So finally, the steel is poured into the mold to cool down into some slabs or some shapes like billets. Okay, so these are then processed to the rolling mills to create a steel grades. Grades means different types of steel products. So now let's understand the business problem. Okay, so let's understand about the business problem. So the business problem is this. So one of the top steel manufacturer in India is facing a problem. Some they are having some trouble in figuring out some steel grades. Okay, steel grades which are the most efficient in terms of energy consumption, production speed, and the overall production. Because they don't know, they don't have an accurate way to classify and identify the best steel grades. So they are not able to optimize their production process. So this means they are not using their resources as efficiently as they could, but which makes it harder for them to cut the cost or improve their operation. So in simple term, we can say that if they could better understand which steel grades are most efficient, they could save energy, speed up the production, and improve the overall quality of the steel. So which leads to the lower cost and the better performance. The objective is to maximize the product efficiency, and the constraint is to minimize the energy consumption and the cycle time. So here we have some success criteria. Okay, so we have business success criteria. ML success criteria and the economic success criteria. So the business success criteria is to improve the production efficiency by 20%, and the machine learning success criteria to achieve at least 95% of model accuracy, and the economic success criteria to achieve the cost saving up to $250, to 250 K dollars. Okay, so for this business problem, we have implemented a high level solution that integrated machine learning solution using clustering, for optimal grades identification and the classification to predict the efficiency, or enabling the real-time optimization of steel production. Okay. So now let's go through the high-level design architecture. So this is the high-level architecture diagram that provides a pictorial overview of the project flow. Okay, so which follows the CRISP MLQ methodology. So the first stage is a business and data understanding. Okay, so where we understand about the business problem and we collect the data and store it in the database. Okay, and then next we perform the exploratory data analysis, or we can say that the EDA, and the data pre-processing or data cleaning. Okay, so after cleaning the data, we store it back in the database again. So we then proceed with the model building and the evaluation phase. Okay, so for that, we split the data into the training and the testing. So the final stage is model deployment. So for that model deployment, we choose a Streamlit framework. Okay, so we choose a Streamlit framework. So let's understand about the data set we had. Okay, so now, we had a structured data set in the CSV format with the 2059 rows and the 51 columns. So it includes the column such as skill grade, batch, and the scrap materials like BSM, PP, remit, as well as energy consumption, cycle time, production, and the chemical composition column like silicon, magnesium, phosphorus. Okay, so since there is no output variable in this data set, so the data is unsupervised. Okay, so it is also primary data because it was collected from the client side. Okay, this is all about the data set. So let's move forward to the EDA. So EDA was performed with the both SQL and the Python. So following 4 business movements, we were analyzed. So in first movement business decision, we have measure of central tendency, where we calculated mean, median, mode. In the second movement business decision, which is a measure of dispersion, where we calculated the standard deviation, variance, range. And again, a third business movement decision, which is skewness. A fourth movement business decision, which is kurtosis. Okay, we perform this EDA. So in this EDA, we perform some EDA pre-processing steps like typecasting. So for the typecasting, all the features had corrected data type. So not perform the typecasting. So then we perform the missing value analysis. Okay, and then outlier analysis. So outlier analysis, we use IQR method by using the box plot method. Okay, IQR and box plot method to identify the outliers. So in this image, you can clearly see for each column, we have some the outliers. Okay. So later, this is a result of outlier treatment using IQR method. All the outliers are removed. So the next is, after pre-processing, we have the model building. Okay. As I already mentioned, we did not have an output variable. Our data was unsupervised. So we applied unsupervised learning algorithms like DB-scan clustering, K-means clustering, agglomerative hierarchical clustering, mean shift clustering, and GMM, Gaussian mixture model cluster, to cluster the grades. So we use some key features such as energy consumption, total cycle time, and production. Based on these features, we define 2 classes: optimal grades and non-optimal grades. Okay, so if optimal grades, so if energy consumption and total cycle time is less than the 75th percentile of one column, and the production is greater than the 75th percentile of the production. So then we can say that this grade is optimal. And if energy consumption and total cycle time is greater than the 75th percentile of own column and the production is less than the 75th percentile, then the grade is non-optimal. Okay. So among all the models, the k-means clustering perform the best are achieving the highest seal out score. Okay. As you can see here, we have the k-means clustering which have a highest seal out coefficient score here. Okay. So after clustering, we obtain a new output variable with two classes. As I mentioned, optimal and non-optimal. So this means we converted our unsupervised data into the supervised data. Okay. So next we use this label data set to train the supervised classification models. Okay. Supervised classification models. Okay. To predict whether the grade is optimal or not. So we applied some models like a decision tree, random forest, logistic regression, support vector machine, k-nearest neighborhood. Okay, and after evaluation, XGBoost was the best model, which is achieving a 99% of accuracy. Here you can see that for the both training and testing accuracy, we have 99% of accuracy for this XGBoost. Okay, so and then later we deployed our model using the Streamlit framework. Okay. So we selected the best model for the deployment. As I mentioned, we use the Streamlit framework here. So here a user can upload the data set and the model will cluster the grades based on our previous logic. Then it will then predict whether the steel grade is optimal or non-optimal. Okay. So, so using our solution, the client can predict the performance of their upcoming production. So this allows them to produce only those grades that are optimal, means which consumes the less energy, which takes a less time for production and gives the higher production. Okay, and also improving the efficiency and the quality of the grade. So these are the prediction results for the test data, non-optimal, optimal, non-optimal. This is the prediction results over here. Okay, and so in this project, we also face some challenges. So let me discuss about some challenges. Like the data set from the client was very large and very messy. So it was hard to understand and prepare. So it had many rows and columns with the missing values, duplicates, and any other errors. So it needed a lot of training and pre-processing. And while feature selection, choosing the right feature for the clustering was tough because there were 51 features, but we could use a few of them only. And the clustering was also tricky since there were no clear differences between the optimal and non-optimal grades or optimal or non-optimal groups. So these challenges shows that the working with the real world data requires a cleaning, selecting the right features, and handling the inconsistencies for the accurate results. So this is all about the project, and thank you very much.